Right, here are solutions to perfect problem 1 for Math 251. Basically what we're asked to do is to either use the definition of the derivative, which I wrote right here, or the difference quotient, which I wrote over here, to figure out these three derivatives. So what I'll do is I'll do it both ways for each of them, even though I only require you to do it one way or the other way. All right, so I guess I should get started. Let's see. In this first one, we got f of x is equal to x squared, so we want to find out f prime of a, and just using this formula right here, I get that that's equal to the limit as x approaches a of f of x, well, f of x is x squared, minus f of a. If f of x is x squared, f of a is a squared, divided by x minus a. And this is a limit you can't immediately evaluate. If you try turning all the x's into a's, you'll get 0 over 0. But there is hope. We can factor the top. We have a difference of squares here. X squared minus a squared is the same as x plus a times x minus a. The advantage of this form right here is we can cancel out this x minus a and this x minus a and get that this is equal to the limit as x approaches a of x plus a. Note that this whole thing is not equal to this whole thing, but this limit is equal to this limit. Basically what we've done is we've gotten rid of the hole that appears in this function, kind of filled it in down here, but filling in that hole doesn't change the value of the limit. But what it does is it gives us a different function, a very similar function, but different, one that's continuous now that we can evaluate. The limit as x approaches a of x plus a, change all the x's into a's and get that's a plus a. A plus a is 2a, which is our derivative. All right, now I'm going to do that again over here, and then I'm going to do that again for 3 more problems. Same thing using the difference quotient. Hopefully I can get the same answer. I know that f prime of a is equal to the limit as h approaches 0 of f of a plus h. Well, f of x is x squared, so f of a plus h would be a plus h squared. From that I want to subtract f of a, which is a squared, and divide by h. It's not a limit that I can immediately evaluate. If you change all the h's into zeros, you get 0 over 0. But there's hope. We can do some algebra here. See, if you expand this all out, if you FOIL a plus h times a plus h, you get a squared plus 2ah plus h squared. That's this. And then we have to subtract a squared from that. That's this. And divide that by h. The advantage to expanding that all out is this a squared and this minus a squared cancel each other out. And so what we get is this is equal to the limit as h approaches 0 of 2ah plus h squared over h. We still can't evaluate this limit. Make all the h's 0, you'll still get 0 over 0, but we can simplify this further. There's an h in every term in the numerator and an h in every term in the denominator. So we can factor out an h and cancel it. This h and one of these h's cancels with this h. And we get that this is equal to the limit as h approaches 0 of 2a plus h. And we finally managed to get this to a point where we can evaluate the limit. We can change all the h's into zeros. We get 2a plus 0, which is just 2a. Exactly what we got over here, which is a good thing. Whew, all right, number 2. Here is g of x. We want to find g prime of 10. All right, using the definition of the derivative first. So the limit as x approaches a to get, so okay, let's write this a little bit better. G prime of 10 is a lot like figuring out f prime of a, except my a value is equal to 10. So what I do is I say, all right, that's the limit as x approaches 10 of, should I write it out, of g of x minus g of 10 divided by x minus 10. And so this is the limit we want to figure out. All right, that's the limit as x approaches 10 of, if you get a common denominator on the top here, multiply this by 10 over 10, this by x over x, you get 10 minus x over 10x So that's what the top is equal to. And the bottom is x minus 10. I'll put it divided by 1, so that's a fraction over a fraction. The reason I do that is because I know how to divide fractions. It's kind of like multiplying fractions, but you flip the denominator upside down. So I get 10 minus x over 10x times 1 over x minus 10. Still can't evaluate this. Try making all the x's 10s, you'll still get 0 over 0. But this form is preferable because I can almost cancel here. The 10 minus x and the x minus 10 almost cancel. They don't quite cancel, but if you factor out a negative 1 from 10 minus x, you get exactly x minus 10. And I guess really I should write the limit as x approaches 10 of this mess. But this mess is a good mess because this and this cancel out. And so now we have a limit we can evaluate. It's the limit as x approaches 10 of negative 1, don't forget this negative here, divided by 10x. We can figure that out. Change all the x's into 10s, get negative 1 over 100. So g prime of 10 is negative 1 over 100. Let's see if I can reproduce that using the difference quotient. G prime of 10 is equal to the limit as h approaches 0 of f of a plus h, so g of a plus h in this case. Remember my a is 10, so this will be 1 over a plus h minus g of a. So again, my a is 10, so this is 1/10, divided by h. So we have to evaluate this limit right here. Try making all the h's 0. It doesn't work. You get 0 over 0. Damn. All right, we can deal with it. We'll just have to do some algebra. This is equal to the limit as h approaches 0. We need a common denominator here. Multiply this side by 10 over 10, this by 10 plus h over 10 plus h, and you get 10 minus 10 plus h divided by 10 times 10 plus h, all divided by h over 1. And this is the limit as h approaches 0. Let's see, 10 minus 10, 10 minus 10 plus h is negative h. How should I write this? And that's divided by 10 times 10 plus h. And to divide fractions, it's like multiplying fractions, but you have to multiply by the reciprocal. So you flip this upside down, we get 1 over h here. So the reason we did all that is because this h here and this h here cancel each other out. We get this is equal to the limit as h approaches 0 of negative 1 over 10 times 10 plus h. And this is a limit we can evaluate. Make the h a 10, or make the h a 0 here. We get 10 plus 0 is 10. 10 times 10 is 100. Get negative 1 over 100. Same thing we got over here. Oh, man. All right, one more of these. I'm glad I only had you do one or the other. It's a lot of work. Now h of x is the square root of x. Okay. Find h prime of 81. All right. H prime of 81 is equal to the limit as x approaches 81. My a value is 81 of f of x. I guess it's h of x in this case, which is the square root of x, minus h of 81, the square root of 81, divided by x minus a. Okay, look at this. Try making all the x's equal to 81. You get 0 over 0, so we're kind of going to have to do some sort of algebra tricks. And our algebra trick in this case will be to multiply the top and the bottom of this fraction by the conjugate of the top. Instead of square root of x minus square root of 81, we'll do square root of x plus square root of 81. And the reason we do that is when you FOIL the top here, you'll get x minus 81. This is kind of, this you could think of as a difference of squares. This is after we factored it out when you have these conjugate pairs. So you multiply square root of x times square root of x, you get x. square root of x times square root of 81, you get the square root of 81x. Here you get this negative square root of 81x, and then here you get negative 81. So we get x minus 81 divided by, on the bottom we have an x minus 81. That's convenient. Square root of x plus square root of 81. Something like this. And I really should have written the limit as x approaches 81 in there. So we still can't evaluate this limit right here, but there's hope. We look over here and we have an x minus 81 on the top and an x minus 81 on the bottom. So we can cancel those out and rewrite this as the limit as x approaches 81 of 1 over square root of x plus square root of 81, which is a limit we can evaluate. Make the x in 81, you get square root of 81, which is 9. 1 over 9 plus 9 is 1/18. All right, finally doing this the difference quotient way, we get h prime of 81 is equal to the limit as h approaches 0 of f of a plus h, f of 81 plus h, minus f of a divided by h. The trick that we'll use will be similar to this trick. We're going to multiply by the conjugate of the numerator. So we're going to multiply the top and the bottom by the square root of 81 plus h plus square root of 81, square root of 81 plus h. I really should have made that in a different color so you can see that I'm kind of just adding it in. So let me redo that. I'll do it in red. We're going to multiply this by the square root of 81 plus h plus square root of 81 divided by the square root of 81 plus h plus the square root of 81. And the reason we do that is because if you FOIL the tops, multiply all that together, what you get is the limit as h approaches 0 of 81 plus h minus 81 divided by h times square root of 81 plus h plus square root of 81. And what you might notice, maybe I can do two steps at once. These 81s cancel each other out, so we're just left with an h up top. But we have an h on the bottom we can cancel that with. So this whole thing is equal to the limit as h approaches 0 of 1 divided by square root of 81 plus h plus square root of 81. We can evaluate this limit as h approaches 0. This is 1 over square root of 81 plus 0, which is 1 over square root of 81, which is 1 over 9. 1 over 9 plus 9 is 1/18. Same thing we got over here. Finally, that is the end of this kind of long perfect problem.